Broadcasting from Boston, Massachusetts, the ARC Digital Transformation Viewpoints podcast is the only podcast dedicated to all things related to digital transformation in energy, industrial, and critical infrastructure applications. The podcast is the creation of the ARC Advisory Group Digital Transformation Practice. ARC advises leading companies on technology trends and market dynamics that affect their business. To engage further, please like and share our podcasts or reach out directly on Twitter at ARC_advisory, or please go to the website at www.arcweb.com.
Welcome to another in ARC's Industrial AI podcast series. Today I'm going to be who leads the Manufacturing Center of Excellence, Amazon Web Services, and he's here with me for another podcast to discuss software-defined manufacturing in the era of agentic AI. Steve, in our last conversation, you laid out what I thought was a powerful vision for software-defined manufacturing, where agentic AI acts as the great orchestrator, turning insights into action, if you like, disparate enterprise systems. It was a compelling look at the brain and central nervous system, if you like, of the future factory. But today, I think we want to take a slightly different direction. Today, I want to bring that vision actually down to the factory floor, to the muscles of the operation, if we're going to use this analogy, right?
Yeah.
Let's talk about the physical embodiment, if you like, of that orchestration, robotics. So how does this software-first approach fundamentally change how we deploy, manage, and scale robotic automation? AI agent decides a production line needs to change. What actually happens at the hardware level, and what is AWS's role in making that translation from the digital intent to the physical action and making it seamless?
Yeah. I think it's quite good to kind of level set here, because I think, when we talk about, manufacturing and, robotics and automation, I think as soon as someone says the word robotics, they jump to kind of like a physical robot, either a material movement arm or kind of a humanoid and type thing. But I think when we look at, using AI, I should say, AI agents and agentic AI, in manufacturing, where the value of AI can come into automating kind of steps, is going to go across multiple use cases, from being used for kind of quality, and actually, understanding exactly the state of a particular product and material, and extending what, we've had for some years, which is kind of closed loop control, to actually, bringing in AMRs and maybe in the future, humanoids to actually perform kind of the tasks that traditionally a human has been done. Yes. I would like to say there is multiple kind of use cases and scenarios in manufacturing where AI is going to be used in kind of this software-defined, robotics automation steps and stages.
Right, Steve. And I'm actually working on a taxonomy for industrial robotics and physical intelligence, right?
Yeah.
And I take your point, because I think there's often, we've been doing industrial automation for decades, obviously, and in some industry it's more advanced than others. And to your point, as I'm exploring it, it's kind of like you've got IFR with a taxonomy for robots, but it doesn't include certain categories that I see as important, like drones and mobile robots. And so I'm kind of working with Patrick Arnold, actually, to kind of put together a taxonomy on all the different classifications that I think we need to think about when we use that term robotics in an industrial context. And maybe it's a good kickoff point, because I loaded that introduction with, I think, what we're going to talk about over the next 2 or 3 questions. But I think it's important because we've been tracking what you've been doing in AWS has been doing in terms of robotics. And we noted that you're planning to sunset, I think actually it's this month, isn't it? Sunset the developer-focused AWS RoboMaker. And apparently you seem to be shifting towards a more composable architecture. So could you walk us through the why behind that pivot, what's going on for anybody that's thinking you're walking away from robotics because you're sunsetting RoboMaker. So I think it's an opportunity for you to clarify that for everybody.
Yeah, I mean, I'd say that, this is a rapidly evolving kind of world we're in, especially with, kind of the evolution of generative AI over the last couple of years, agents. And now what we're kind of probably going to be talking about very soon is kind of like, the physical AI. And, as this world is kind of evolving, we're always looking at, how do we support our customers and partners, better? And obviously the technology, the needs from our customers is, changing. And hence why kind of like we're our pivot, from, where we were probably seeing the industry and the needs of the industry, 4 or 5 years ago to where the industry, is, and also like partners like NVIDIA and, their Easy Lab product coming that's really kind of enabling kind of the whole physical AI and, just driving the intelligence needed within kind of software-defined manufacturing.
Yeah. So what market signals led you to kind of make this transition to more, I guess, foundational services like AWS IoT for connectivity, AWS Batch, I think it is, for simulation, and AWS Step Functions for orchestration, rather than that single monolithic robotic service that I guess RoboMaker really was?
Yeah. I mean, really what it's seeing is that every customer and partner, have their own unique kind of requirements or their own set of use cases. And really what we want to do is enable them to be able to do what they need to do. First of all, kind of data is kind of key to be able to train, traditional machine learning model for kind of, object detection as an example. So that's where like our services like, AWS IoT Core or Kinesis Video Stream really come in, bringing data from the shop floor environment into the cloud. And then we've got our services like AWS Batch or Amazon SageMaker for being able to kind of train those, models. And then we then have the Amazon Bedrock and, the recent announcement of Amazon Bedrock Agent Core for being able to deploy those foundational models, in most cases, LLMs, into those agentic AI use cases. I mean, a lot of our customers are still very much kind of at the early stage of, still bringing their data, understanding their data. And again, I know not specifically to, today, but, generative AI, is very much leading itself to be able for manufacturers to be able to understand and catalog their data and bring and turn it into information, and then kind of bringing in our, our partners. And there's a whole new, like NVIDIA, and there's a whole new world of new AI startups that are focusing kind of on the physical AI to be able to, build those foundational models as part of that.
All right. So this kind of pivot you've made to a more composable approach better addresses the core enterprise challenges of integrating and managing heterogeneous multi-vendor robot fleets, rather than your being prescriptive about how to do it. And
yeah, I mean, yes, I think as we both know, there is very few kind of greenfield factories out there.
Right.
And even if it's a brand new greenfield factory, there's probably not just going to be one automation vendor in there type thing. So, we're very much looking at, how do we enable the seamless integration of all those different control systems, robotics, and enable kind of the orchestration, across that.
All right. Well, look, we should probably, before we get too obsessive about the services themselves, we probably need to take a step back and talk about what we kind of teed up in the first episode. You talked about, and you've talked again today, about physical AI, and I think we talked about embodied AI last time as the next step for industry. So can you define those concepts for those listening, how they differ from traditional automation?
Yeah.
Moving, because I think if we think about the way we've used robots in the past, some of the limitations have been very difficult to program. They kind of are very fixed in what they do. They're great at what they do, highly repetitively. So they're pre-programmed and can be very efficient. But I think we're really talking about a move more to, the fact that they can perceive, reason, and act in a more dynamic way.
Yeah. Yeah. Yes. So just going kind of touching on what you just slightly spoke about, if you look at, a traditional automation system or kind of robotics, they have been programmed to follow a particular sequence. As part of that sequence, there may be inputs and outputs that are used to determine moving on to the next step or what particular operation needs to be performed, but it's following that sequence. And there's multiple kind of the internets out there that can give definitions of physical AI and embodied AI, but in a nutshell, the way that I describe physical AI is as an autonomous system, like a robot, like an AMR. You can even think of as a vehicle that's doing kind of level 3, level 4 self-driving, that basically understands the real world around it and uses AI to be able to perform tasks in that kind of real world. And then within physical AI, there's a subset of that called embodied AI, which is the kind of the integration of AI into those physical devices, be it the AMRs or the kind of the robots and so forth. So a good example of embodied AI is what Amazon's done themselves in our fulfillment centers. With Robin, we've got, if you go and search on YouTube, there's videos of it out there, and even on the Amazon website, of a FANUC robot that's actually got a camera on top of it and a vacuum attachment. And as packages are coming down the conveyor belt, those packages are actually in random, places on the conveyor belt, and it's able to detect where the package is, the orientation of the package, and be able to pick it up using the vacuum gripper and then move it and place it into a cage for transportation. So that's a great example of kind of, my point, embodied AI, got a physical device where AI is being kind of integrated into it to perform an autonomous task. So.
And I was going to ask you to give me an example to make the point, and you did, and I was going to suggest it could be AWS themselves, because I know that you are on the forefront of this and using it in your own supply chain. But I think it might, let's take it a step further. Can you maybe just talked about what it's doing, but what are the AWS services that a manufacturer or I guess a robotics OEM would be using to make that happen?
Yeah. So, I mean, there's going to be kind of multiple stages. Obviously, there is the development, capture of the data, training of the machine learning model, and kind of validating, that model before it's actually kind of deployed. So that whole kind of ML and development, ML ops workflow. So we'll see customers use services like AWS IoT Sitewise or AWS IoT Core to be able to stream data in from a robot or kind of an automation system. In some cases, customers may just kind of take a set of data and just kind of upload it into an Amazon S3 bucket if they've already got that, a subset of data. Also, we're starting to see, customers look at using services like Amazon Nova to actually generate synthetic data. So especially if you need kind of images or videos as part of your kind of your training data set to make sure you've got all those kind of scenarios addressed. Once that data's there, customers use services like Amazon SageMaker to be able to train that machine learning model. And then once that machine learning model is kind of built, trained, and kind of validated, it then needs to be integrated into that actual process. I think in most cases, this is going to be kind of probably, if it's going to be a industrial automation, robot or kind of system, it needs to be deployed down to the edge.
Right.
So, services like AWS IoT Greengrass kind of enable it. We have, partners that offer kind of industrial gateways that have GPUs in them for that inference. So from the cloud, we deploy them down. And then services like AWS Systems Manager, for example, can be used to actually manage and ensure that device is secure, and you're constantly making sure that you've got that updated machine learning model there.
Right. And I guess you kind of started talking about the DevOps cycle, right? In many respects there. And that was going to be my next question. You know, a core promise of what we talked about in the first episode was software-defined manufacturing, bringing modern software concepts and practices to the factory floor, which has maybe fallen a little bit behind in terms of, and I know there's going to be lots of people listening for good reason, very conservative, ultra safe. We obviously, in many cases, have to worry about safety. We have to worry about compliance. But to some extent, we may have fallen behind on our and been pretty rigid in terms of our architectures and our practices. And we talked about that somewhat in the first episode. So can you talk about, and you started talking about really the concept of industrial DevOps with that example in some ways, right? The whole process of going through it. So you started getting into, I think, cloud-based version control, right, which could apply to both PLCs, right? So the traditional industrial automation, but also into the robot code and how that gets managed and updated during the life cycle. So can you maybe just flesh that out a little bit more in terms of what you're seeing? Or I know it's early days, but you are on the forefront of it. So it might be a good teaser for people on what you're doing at AWS or Amazon.
Yes, so I think this is, as you say, we're very early days, and I know there's going to be some people probably, shouting out at kind of whatever they're listening to this podcast on, saying, there's safety critical. So I'm saying this, as you said, kind of like, ensuring that the safety critical systems are actually kind of protected, and, the robots are going to be probably still in cages to a point in time. But saying that, we are seeing customers integrate and very much go down kind of this embodied AI, either it's for, doing quality control using kind of computer vision, or in kind of process, doing kind of closed loop control and changing key KPIs settings on the machines based on kind of the output to, kind of meet that kind of, that golden batch. But if I I always like to use the quality use case, historically, even if, a machine learning model has been used for quality, there's still a human in the loop. There's still a human there seeing kind of the output of the machine learning model, saying this is, a defect part, or this is good, this is bad, and so forth. And they're making a decision to actually reject, stop the line, whatever it may be. But now what we're seeing with kind of like agents is that these agents can be used to actually, orchestrate the multiple steps across those tasks. So, the registering of a non-conformance is still going to be done in an MES system or a quality management system. But how do you kind of integrate the machine learning model, that's determined that there is actually a defect, with the MES system where that's actually going to be kind of registered type stuff? So this is very much where we're starting to see, AI agents really kind of come in. Same around kind of maintenance, condition-based monitoring. I'm starting to see kind of anomalies in, high-valued equipment, and then raising service requests or service tasks, in the maintenance system. We touched on this slightly last time. And then kind of, from there is, okay, then you can start looking at, you've just started to automate kind of tasks. Then you can start going, okay, or multiple steps. You can then start to go look at how can agentic AI actually do complete kind of, workflow type stuff. And I think this is very much on the forefront, but this is very much kind of, the art of the possible. So We're identifying defects, we're raising non-conformances, and, the agentic AI system can now actually determine the reason why that defect is happening is because a key variable is out of alignment, and potentially actually do kind of feedback automatically into that control system to make that particular change, so that that defect's not being kind of created. In that case, obviously, you've got ML models that kind of running, detecting defects. You've got your MES systems, your system records.
Mm-hmm.
You've got all your standard operating procedures that are going to be kind of used as part of the reasoning for the agentic AI. And then potentially you've then got your MCP server that's kind of sitting, in front of your control system that allows you to understand what your current settings are and potentially what needs to be kind of changed to actually make sure that defect's not being created.
So we tend to started off with this conversation, right? That robots, everyone immediately assumes humanoid robots and has some fixed ideas of what they've been able to do in the past. And I'm glad you brought it back around to agentic AI and how agents across different systems will all be orchestrated, working together, right, to provide context for these robots so they can kind of talk to each other. I'm not saying robots necessarily talking to each other, but in some cases they may well be telling, hey, you need to stop there until it's safe to move or whatever, right? So I think there's an interesting mix here of the software orchestration, sensors across multiple systems. It's not all going to be, I've got this super intelligent robot with a brain, right? And we're going to talk about the brain probably a bit more in the next episode, right?
Yeah.
But I think what you're highlighting really is we still need all of these tried and tested techniques for computer vision so it can see, right?
Yeah.
You still have to have sensors that enable it to move around. You still have to have coordinates and 3D space for it to be able to understand. But we now have these agents kind of working all around it to kind of keep providing that context, right?
Yes.
And getting updates from different systems. So I think there is something that you teed up at the front that I think when we talked about that pivot maybe on how you'd move to more composable services, and it hinted at AWS's work with a much broader ecosystem. So maybe we should talk about, obviously there's a big company called NVIDIA out there, right?
Yeah.
That's driving a lot of thought leadership around physical intelligence as well as Gen AI and all the work that's gone into that. But maybe let's talk about the ecosystem, Siemens, Rockwell, the traditional industrial automation players, the other robotics companies that many of us have known for years, the KUKAs and the Kawasaki's and the Mitsubishi's, and I'm sure Universal Robots, and there's a whole bunch of them, right? And that's forgetting the startups and I guess Sarkos Robotics is another one I've worked with, and Spot the Robot, you name it, Boston Dynamics. So there's lots of different types of robots and formats and innovations going on there, and that's not going to slow down. But maybe paint this picture of how you're working with the ecosystem to kind of make sure that this happens responsibly, safely, productively as we move forward, because that's always the fear, right? Everyone's suddenly going to have Terminator pictures in their head, but I'm sure we're not there yet. But
no, we're not there yet. And I know there's new ISO regulations coming in, I think in 2027, I believe, if my memory serves me correct, which is actually taking into account kind of physical AI and humanoids, and I believe part of that standard is that they're actually saying that they still need these to be operating in caged environments. So I mean people don't need to worry too much. But yeah, I mean, to your point of what you described, and even like that whole kind of use case workflow I just went through there's so many different components there, and we're very conscious that probably a manufacturer is probably not going to have the skill sets to be able to achieve that, from end to end by themselves. They're going to need their partners, be it an industrial automation partner like a Siemens or a Rockwell, a robotics, a partner like Fanuc, KUKA, ABB, and then obviously, the AI kind of, partner ecosystem to really kind of, come together to be able to kind of build these, physical AI systems using, and applying kind of agentic, to that. And that's why we're very much from an AWS point of view, focusing on kind of enabling this. With the recent announcement of Amazon Bedrock Agent Core, it's really to provide manufacturers their partners, either a systems integrator or, industrial automation vendor, be able to deploy and operate AI agents securely at scale type thing. So that's really kind of where we're kind of focusing and really working with that partner ecosystem to enable them to build the capability to be able to deliver that to the manufacturers themselves. So, they don't have 10,000 Lego pieces. They've only got 5 Lego pieces that they actually need to put together. And, hopefully with, what the OPC Foundation's doing, with OPC UA, with kind of UNS, which we touched on slightly in the previous session, and with MCP, those 5 Lego pieces that need to be brought together to actually enable this are going to be talking kind of the same language natively. So there's not going to be a need for kind of a heavy lift of integrating all these different parts and components. So that's really where our focus is.
Yeah, and I'm excited about the potential. I did a whole series on MCP and A2A and AWS strands, some of your contributions to evolving standards and productivity in the agent-to-agent orchestration space, right? So I feel good about the way the technology is evolving to make interoperability across kind of the new stuff and the old stuff, because that's always the challenge, right? The legacy is we can't afford to rip and replace it, and yet, to your point, we've still got lots of brownfield sites where we need productivity, we need to move forward, but we can't just build a new factory every time, right?
Yeah.
So I think that interoperability is important. And I'm excited about what NVIDIA is doing in particular with Thor and putting more and more capability at the edge.
Yeah.
Because it is kind of, as it has been, we've never really been able to move everything to the cloud, and we're still not going to. We need that autonomy on the edge.
Yes.
Yeah. So I think seeing that horsepower, or should I say robot power, I guess we're going to have to come up with a new name for it, right? But that capability at the industrial edge, I think is a really important evolution to make, AI on the edge more broadly, not even just for physical intelligence. I think more broad deployment and scale out of industrial AI is going to be helped out greatly by what NVIDIA is doing. And I think we'll talk a lot more about that in our next episode, where really we'll get more into the brain, right?
Yeah.
The digital twin and how you have to have digital twins to really make any of this stuff happen. But let's save that for the next episode. What haven't we covered today that you really want to? I know you're fresh back from, was it IAA?
Some of my peers were IAA this week. I wasn't. Okay. No, right. I wasn't. So, but I do have SPS Atlanta next week. So. Yes.
Okay. All right. So is there anything I should have asked you that I didn't? I always like to ask that question, right? Because we don't script these out, right? So we have a couple of things we want to talk about, but what haven't we talked about that you really wanted to talk about on this episode?
No, I think we've kind of touched on, all the kind of the key points. Is like, I think, kind of reiterates that there's lots of terms. Hopefully we've kind of given a little bit of clarity to these terms of, agentic AI agents, physical AI, in the terms of software-defined manufacturing, which is kind of, umbrella talk. It's not going to be this, like switch. Let's going from where we are today, to, AI kind of everywhere, and all factories are basically what lights out, which is a term that I'm sure will get some people going.
I hate that term. I hate it with a passion.
Yeah. Yeah. Really what I envision is it's going to be, it's going to be, a staircase of getting to where manufacturing needs to be, and really kind of looking at it from each kind of use case perspective, and very much for, the manufacturing leaders to, look at, okay, how can we use, agentic AI to really kind of drive operational efficiencies and automation on our physical systems, a production line, a robotic cell as an example type stuff, and how they can deploy that securely and safely and at the low cost as well.
Yeah, and you've kind of touched on a pet peeve of mine, right? I still think we're going to see a lot of human in loop for some time to come. We're going to see. So I don't think we'll see many lights out. I'm not sure what that term means, but if you mean totally autonomous,
yes,
or totally automated factories, there's not many of those in reality, right? So I think but having said that, we have lots of use cases, and you mentioned like AMRs, we're kind of used to warehouses where robots are doing a lot of functions and they don't need a lot of intervention, right? And similarly, we've got used to in utilities and elsewhere, drones doing inspections and other forms of robots doing security. So, I mean, I think to your point, it's an evolution as they get smarter and smarter. I shouldn't use that word because then people...
More capable.
What is it? Anthropomorphize or something like that. I'll have to correct that word in the recording. But yeah, people make them seem like they are human-like. But as they become more capable, to your point, we will see more and more tasks that may well be performed almost autonomously.
Yeah.
So, and a lot of that, though, depends on this capability that we're going to talk about in the next episode, I think, which is the brain of this system and how you're going to train it, for specific functions, how you're going to make it adaptable, how you're going to make it be able to respond more dynamically to what's going on around it. And that is that complex equation of agents and sensors and the capabilities of the robots themselves. So looking forward to that one, because I think we're going to get into some of what you're doing, some of what NVIDIA's been investing heavily in, and we'll get back to one of the key topics that I think every manufacturer can relate to, which is the idea of digital twins and why you need digital twins.
Yes. Yeah. Because, to not go into the next episode, but to truly be able to deploy, an autonomous robot to perform a task, you're going to need that digital twin of the physical environment to be able to train the AI within that robot to be able to perform those kind of operations. So yes, digital twins are going to be key to unlocking and enabling this from a manufacturing point of view.
All right. So with that teaser, Steve, this has been a fascinating look at how software is truly meeting the physical world. We've covered the strategic shift to more flexible, composable architecture for robotics and why AWS has made some pivots on some of your services. And you've given us a glimpse into the future of the rise of physical and embodied AI. So the muscles of the factory are becoming more intelligent and coordinated than ever before. But really, I think it's in our next episode, Steve, where we'll dive into that brain of the whole operation, the digital twin. So we'll explore high-fidelity virtual models powered by simulation and digital threads, and how they're really have been all along, but are really becoming the essential engine for achieving closed-loop autonomy in manufacturing. So thanks for your time today, and I'm looking forward to that next episode.
Excellent. Once again, thank you for having me, Colin, and have a good day.
Look forward to it.
Cheers.